All right. How's it going, everybody?
Oh, oh,
I'm Philip. I'm here with Dane. We're going to give you guys a volcano update here, both for Mauna Loa and Kilauea. Dane's checking out our sound. Sure, we got everything dialed in here. But just wanted to kind of share the way that we've been switching our thinking about volcanoes. We think about Mauna Loa first nowadays, and then Kilauea we think about as well, of course. But we're kind of catching a vibe of everyone out there in the community that's kind of got their minds on Mauna Loa first. Whenever I come across anyone
right.
they're asking about Mauna Loa. Of course, HVO USGS just raised the VAN notice for Mauna Loa to basically level 2, the yellow.
The advisory.
The advisory.
Advisory yellow. It's been a little bit of a long coming on this one, a few months coming. I mean, they started talking about the possibility of raising it 3 months ago or so.
Right.
And now we're at a point where it's the prolonged elevated activity above background levels has justified the elevation of the level. So in the last update, their monthly update, HPO went ahead and raised the alert level.
Right. And we've been covering this kind of increased activity for a while. Kind of give you guys an update on what's changed, like in the last couple months, maybe as far as that activity. But we had, before this, previously actually talked about how we could have been justified leaving the alert even at yellow that entire time without dropping it down to green necessarily, given the history of how they've manipulated the alert and not put it up, not put it down. And we talked about how there's some kind of art to it, and there's some kind of judgment call of exactly what's the threshold, that kind of thing. So
it's still a pretty new system, and in its time of existence, Mauna Loa has been in a non-eruptive state.
Right.
So it's at its still a point where it needs to be stress tested in those regards.
Right.
Like, how does it react? We know how it reacts on Kilauea now. We've now seen what green looks like on Kilauea.
Right.
But we're just coming out of green back into yellow on Mauna Loa, so we're gonna see how that progresses. So you want to just immediately dive into the data?
I don't know if you want to show. There's actually the most recent Volcano Watch. There's a graphic that kind of shows the levels of the green, yellow, orange, red, different levels of the volcano.
We're live.
We basically, one way to think of it is a 4-tier system, 1 through 4, right? Let's call green 1, let's call yellow 2, let's call orange 3, and call red 4, right?
Yeah.
So
exactly, and we're still defining exactly what all those thresholds are. So it's really interesting to be back in yellow again, because that was the prolonged state between 2014 and 2017 or 2018 until the alert level went down.
Right. Yeah, so we've moved from a 1 to a 2. We're not 3 yet. 2 can lead to 3. 2 can also lead back to 1, and that's kind of what's not clear right now. So let's sort of kind of just mention that. We'll look at the Mauna Loa GPS now. And talk about the history of the alert, kind of in that context, and point out like maybe where we thought it could have even gone to an orange. We've kind of been discussing that like back in 2015. So we'll show you guys that. Let's switch over to the GPS plots on Mauna Loa.
And we're doing the Mauna Loa first, just because it's at an elevated level. USGS has raised the alert level, and Kilauea is still at what we consider background levels. And we'll get to it, but there's really nothing outside of our last update.
Right.
So we'll get to that. But yes, we're going to start with Mauna Loa today.
So, all right. Let's see. We have kind of 2 ways to look at this, right? Here we have on the screen, we have the GPS plots, or 2-year plots. Right here, this is Mauna Loa Strip Road. And we basically have a signal, showing a big jump during an earthquake last year, right over here, right? And it's basically been stabilizing pretty normal right there, right? We don't see kind of any major adjustment in any of these kind of signals. That's true of most of these stations. The scale on the side of this signal is one thing we always look at is the scale. It's very, very tiny in these plots, so clearly it's showing the effects of the earthquake and some settling afterwards, but there's really nothing convincing happening at the tail end of these.
Right.
Let's switch to that 5-year, the 5-year look back plot, on Mauna Loa, and this is on the USGS site as well. So maybe scroll up and just kind of orient people where we are on a web page, so that if they do follow, right. So on a main HVO website, if you go and click Mauna Loa monitoring, and then you go to the side, and you can kind of see kind of behind Dane's shoulder up there on the screen, it says like data past 5 years, right? Kind of get to there, that orange link. Yeah, here we go. There we go. Look, we got a little drawing pen, right?
Yeah, this is the John Madden pen. That's its new name. All right,
we're breaking out the John Madden pen. Maybe we can make it a little thicker.
Yep.
Make it a little more obvious what we're talking about.
All right, here we go. Bam.
There it is. Yeah. So okay, past 5 years. That's kind of where you click to get this kind of display. You can see right above there. There's a past year, past month, past week. So these different. It kind of automatically frames different amounts of time and shows you the data kind of slice just for that amount of time. So we're looking back 5 years because we want to talk about this past alert notice, and elevated rates. Mauna Loa hasn't changed a whole lot, like month to month. We want to look at that in this kind of scale and detail. So let's kind of scroll down from here, right? This kind of upper plot just kind of shows where earthquakes are happening. It's kind of the areas where they normally happen. There's kind of one cluster to the northwest of the main caldera cluster right over here, right? And we're kind of just going to bypass that for now.
And those that go back and those are the historical areas of activity.
Right, right.
And well inside normal background levels have earthquakes there.
Yeah, and we're going to bring that up a lot today, right? What is background and what is above background today, right? So when you're looking at this plot of earthquakes, this is the background activity of Mauna Loa, kind of normal volcanic life, let's call it, right? It's not dead. It's not like not doing nothing. Right. It's doing something, but what it's doing is at a normal background level. Right,
but the interesting thing about this one is that it just becomes a bunch of noise, and that there's so many overlapping red dots in this saturated area.
Right.
But it gives a good idea of what is background. But we will get into why we consider it now elevated background.
Right. So the second plot here kind of just is like a cut going straight across, right? The colors basically show depth, though it always looks this kind of rainbow kind of same exact pattern right here. And so really what Dana is showing is there's no resolution to see anything that's happening right in here, right? That's kind of, I'm sorry, up in the area up here, what we're really interested in is like area, let's say from 0 kilometers down to 5 or 10 kilometers the most, right? And we really can't see any detail in there. It's all just too many earthquakes, all blown out. So we're gonna keep scrolling down, and we can talk about this plot right here, and maybe we can blow it up even if we. That's fine. Let's leave it as it is if you just click on it. All right, so take control of the John Madden pen here. And this is earthquake rates and depths, right? So the depths are kind of below, the rates are kind of above, right? And this is a very, very crude first order way of kind of trying to figure out what's happening, if there's anything happening at all. And kind of after you kind of see these numbers, you can go and look in more detail at things like deformation or exactly where,
Right, and the other thing to note about this period in time between 2017, so right about in here, or even 2018, so let's go up to this eruption, and all of this were at elevated yellow at that point, considered officially at a yellow ranking for Mauna Loa.
Right.
So this whole time is yellow. We then get green in 2018 following the Kilauea eruption, and then it continues on until we get this a little bit of elevation. This little mark is kind of where the first talks of elevating Mauna Loa, when does it happen, begins. And now we're here where Mauna Loa does get elevated.
Right, exactly. Yeah. So kind of the thing to kind of realize is, so maybe I may scroll with this, not unless I get out now. So maybe let's go to the GPS and come back to this, because I think the GPS is kind of what tells a story. Scroll down. Right there, the GPS caldera line length shows the difference, of what happened in Mauna Loa, right? So what you guys can look at is that, we're looking at the left end of this plot is lower and right, so the whole thing is rising. This is basically showing the distance between across the summit caldera of Mauna Loa has been increasing. And it can increase at a fairly steady rate, and that steady rate might look like something like that, right? You can kind of see we deviated from that rate, and kind of we went higher than we were before, and then slowed back down, and we've caught back up to that rate, and we're kind of still going, right? So the important thing to realize is that this period right in here, we were still at yellow, and this is the era that we were saying maybe, you know, if someone had decided to go to orange, that could have been justified as well.
Right, the system's still so new and still getting defined that there's no really hard and fast rules on when you raise it.
Right. Because you can see that these sections of the line have different slopes. Right here, it's kind of flat. Like right there, it's kind of steep, and here it's the steepest. Like this area right in here is your warning signal, right? Like you've gone from a high rate to an even higher rate, right? And so that's what we'd be looking for maybe raising the alert the next time on Mauna Loa, right? What we're looking for, people are asking what's happening with Mauna Loa, and the short answer is right now it's basically still has a heartbeat, right? But where it hasn't shown this sign of it actually moving towards the surface in any kind of pulse or any kind of forceful way, right?
And then we get the green, so life of the green signal during the 2018 eruption. And then we can see how it's pretty flat in here, and it picks up again, right?
Right.
And so we have our little green zone.
Right.
And we don't get that thing for long. But we do get back down to what is considered background levels. Now, the interesting thing is if we scroll up a little bit and check out the tilt, or not the tilt, the GPS, or sorry, seismic. Let's just go through all of them. We go to the seismic. You can see in 2014, with our 2014, 2015, we don't have much in the way of seismic comparably. Like we had a stint in 2018 where we were at that similar levels of earthquake activity, but didn't have the deformation.
Right.
In order to keep it at green. But now we have as we just showed, the GPS elevating from the trends following the 2018 eruption and during the 2018 eruption of Kilauea.
Right.
That now we're getting into a point where, okay, we've picked up both seismic. And obviously on the seismic, when you look at these last few months.
Yeah, so the seismic's up, but we're still kind of waiting for the GPS signal in summary, right? So, you know, like this time the seismic is kind of tipped the balance, right? Let's say, right? If you guys look at that, the right end of the plot here, you can see that even now, the last few months, we've had higher earthquake rates, really consistently over, let's say, 3 months back to back than any time since that alert, you know, went up in 2014. Now, that in itself is not cause for alarm, right? That's just cause that to notice the thing is awake, and you know we are all aware of that, you know. So, and you know we are watching closely for the actual signals that will show something impending happening in a more imminent time frame. You know, as soon as they are readable and observable, right? You know, some of these things don't manifest, you know, until not that long before an eruption might actually happen. But that's all you got to go on, is how the Earth actually shows you.
Right, and we also get these little flurries of earthquakes, like this bad boy here and this bad boy here. And no eruption follows it. Right. And these were really interesting when they happened. Yeah. But then it just fell back off to about comparable levels afterwards, like right here and right here.
Right.
Like the next month, it's like, okay, I guess never mind. But it's interesting, like academically, but for the common guy, it's like you can get pump faked by Mauna Loa pretty hard, especially since we're using the John Madden pin. So.
Right. Earthquake rates are just kind of one rough measure, you know, of kind of see what's going on, and kind of, you know, it's something that if we hadn't been paying close enough attention before, then it's reason to pay closer attention. So HVO clearly saw that. That's, you know, the main basis, right? They also mentioned deformation on the surface. You know, we have not had a benefit of seeing any INSAR on Mauna Loa of any time recent, so I'm not sure exactly what that shows. We'll take their word that there is deformation happening there that they can read. And I'm sure they'll show it to us when they can, but we don't have that to show to you right now, but I'm sure there's some evidence of that. We don't really look at tilt plots in Mauna Loa at this point because, you know, that is detecting fairly shallow changes that can, you know, at this point, we don't believe the magma is at those areas causing those tilt changes necessarily, so it's hard to say the tilt is for this or that. Maybe like if we're in an orange alert situation,
then it's time to
verging on a red alert situation, then we're looking at a tilt at that point, right? At this point, it's kind of too soon to look at that. Those kind of minor changes are not really telling us what we're looking for.
That also kind of goes for like a thermal camera up on Mauna Loa Summit. It's like, okay, seeing it pick up in heat suddenly. There's going to be other explanations immediately for that increase than, hey, it's Mauna Loa is actually increasing. You'd expect late in the situation,
Right.
not an early stage thing. We're still in early stage.
Right. So, I mean, this is a great time, speaking of Mauna Loa, for everyone to kind of just, it's a great time for education and preparation, those kind of things, right? I don't think that we need to like be packing anything really anytime, like, nothing's going to happen tomorrow, actually, so we're not to that phase of it, but like, just being aware that this is where we live, or, I didn't realize I lived on Mauna Loa. If I live, some part of Hilo or some part of Puna, right? I might be surprised that, driving along Highway 11, like from Hilo to Volcano, right? It's actually around Glenwood that you cross onto Kilauea. Anything below Glenwood's on Mauna Loa. So maybe we're not all aware of exactly where we are. Not to say that everyone's got an equal threat of lava flow, but that's this is a good time to be thinking about those things and looking into that, and
So what I immediately go into, what is the most likely case in this, situation? Well, we'd expect if Mauna Loa is leading up to an eruption, we would see more indications of that via the monitoring equipment in place.
That's right. Yeah.
The second thing is via the historical record, we would expect any eruption that did take place at this, if it were to take place, would take place at the summit first before trying to migrate down the rift.
Accompanied by lots of earthquakes.
Right.
Not like the kind of earthquakes we've been seeing so far, but like really lots, like hundreds to thousands.
Shallow earthquakes and in key areas at key depths. Right. And that's the thing is, even we just saw on Kilauea, you can have an earthquake that looks like South Flank. It's on a magnitude in an area that looks like South Flank, but then it's at a depth that it's like, okay, never mind, it's not South Flank.
Exactly, yeah. I know, I mean, that just happens to project onto the map surface. That thing is farther away from the surface than anything else. And at that point, using the actual surface of the Earth's features is kind of silly.
Right.
Like, the most important thing is how far down it is, and nothing else really matters.
Pretty much.
At that point, yeah. That doesn't even feel like that stuff. So, that's kind of the face of Mauna Loa, right? So, it's, we're kind of looking for the GPS. We're looking for, INSAR signals to be released, if actually would show some kind of change there. And so far, like, there is nothing worth talking about there, right? So we're kind of still watching, but maybe now is a good time to transition back to Kilauea.
Yeah, let's do that. Bring up the GPS on Kilauea.
I suppose maybe you can just mention that last screen that you're on, like the Mauna Loa one. Kind of just in the ending, I can like look at the right end of this plot over here, right? There, like that's where we are right there in that phase. Is just before any kind of increase, and so we may not actually right in there kind of compares to, and then draw right in here. Something like that, right? So if we don't get that bulge that follows it coming, then
yeah, it could sit at this type of rate and go like that. It could go up. It could level off. It could do all kinds of things at this point in time.
Right.
Like, so there's no certainty on this bad boy.
Right. But certainly before it goes really steep, it has to do what it's doing now. Right. So that's kind of why now we're looking at that possibility. That's kind of where we are. So, okay, let's fully shift gears to Kilauea. And Kilauea is still at alert green. There hasn't been a whole lot of change on Kilauea as far as any data that's been put out. But one exception is that since my personal last update, which has been a while, I've been doing some traveling, that there was released the INSAR of the summit of Kilauea, right? I still would like to see the INSAR of the South Flank and of Mauna Loa and some of the rest of the island, but this is what we have released right now, is this INSAR of the summit. And this covers basically the months of April and May at the summit. And this was a volcano watch from the beginning of June. So you guys can go back and find that on the USGS HBO website as well. And kind of what there is to see here is that there is if you were to read their caption, they basically say there's two areas of deformation. One, they've kind of drawn with these plots right here, 1, 2, 3. So the center of it is kind of right in there.
Yeah. Sorry, let me give you a different pin.
The center of it right in there, and just a little smaller. And then the outer band of that one seems to be something, it's hard to tell because there's some topography right here. That's a cliff, right? So the inner kind of collapse area. But maybe it's going something like that, kind of around here. Like that might be the area, right? So this is kind of what I've been referring to as the bulge, right? When I described earlier that there was some tilt and some GPS showing uplift on the caldera floor, right? We had already said, okay, well, if I have a station on there, it must mean it's on this shelf right in here. So this is likely the area that's actually putting up. And here's a map, and it shows exactly that. And the inflation is right there. I'm not sure where the station is. It might be somewhere over here, something like that. So they also talk about a second center, and that being located right around here. And that one has outer rings. So the rings here is kind of, I'll trace a pink because it's easy to see on the screen. Pink. There's like kind of pink right in there, kind of. Right. In this case, the pink is kind of goes like that. It's not really clear. It kind of like what's going on here. There's like a little transition zone. There's another pink circle way out here. Right. So we almost have like a shallow bulge right here, and then this might be a deeper source that's much broader, right? So the inner collapse of the caldera is about 2 miles across, right? So we're looking at this range right here might be in the order of a mile or a little bit less, something like that, between this range, this radius, whereas we're looking at probably a 2 mile radius out here, right? So we're going 3 bands up. This is the way this kind of works: is the more different bands of the same color you cross, the more deformation there is. In this case, they're both upwards. We'll just take the geophysicist's interpretation for that, because it's easier than trying to teach you guys how to do that. So these are both up, but this is like up in the middle, and this is about 5 centimeters, 2 inches worth of bulge kind of in the middle. And there's in this case, a little bit less than that, right? Like 3 point some centimeters.
I thought it was like 6, but anyways, it's less.
1.6 centimeters like per band, right?
Oh,
so
yeah.
if we count like 1 band, 2 bands, for example, right, then we're looking at 3.3-ish bands right there. Right, so this might be like the actual deeper bulge, right? So if we kind of took this on its edge, and I'm gonna kind of just draw over top of this, the caldera is shaped something like that, right? Then like somewhere deep inside of this collapse plug that's in here, right? We have some piece of magma that's like bulging up a little bit, but it might also be kind of pushing out something like that.
Do you want a white sheet to do this on?
No, I'm just going to leave it at that, and I'm not going to complicate it much, right? So, right, so this would be magma right in there, right? And so you have a little bulge on the surface happening right here on a small scale, but you might have like a larger bulge that kind of comes from here, right? And this span from here to here might cause like a larger bulge from deeper, right? Something like that. Right. That's kind of cut through, looking at this map, more or less what you might see, something like that. So that's interesting because, what we've kind of, in the past pondered, if magma comes back up through this rubble, must it push back through the rubble, might it come up squeezing through the edge? And we kind of have 2 candidates, right? Like, this could be something like, this could be like a flattish pancake, but it also could put up some kind of finger like that, right? And if that happens, then the center of this upper bulge may actually be more offset, right? Like we see here, an offset between. So that's an interesting kind of feature to kind of see. And this is only 2 months of data. That's something to keep an eye on looking forward, like for those of us that are kind of combing through the data with a little bit finer tooth comb, right, to kind of see what might actually happen at the summit. There's still no sign of any gas coming out there, which is really the key thing to me still. Like I've been saying that for months and months and months. Until that happens, this is all kind of just novelty underground. Like where might it pop up? How long might it last? Like, it doesn't seem like it's going very fast in this area. So I wouldn't expect it to really start pooling into that hole and filling it up and kind of going nuts with lava, anytime soon. It might pop out and leak out, and it might do that possibly without a whole lot of fanfare, right? Because if it's going through rubble or through some crack, it might just leak out a little bit and seal itself back up. In any case, all that has been released, and all that we know of this change is all on the summit, in the summit area, and we have heard that there is something happening, like there's kind of still deep refilling on a east rift that the INSAR is showing, but we don't have access to that imagery to actually look at that.
All right, so let's transition now to the lower east rift zone. This was, there's really not much changing overall on the lower east rift zone. This is one of the few places that there is some change. This is off of Ala Ili, and you can see how the steam is still working its way up rift. That's one of the only real notable changes that is happening, and that's a slow, drawn-out process where it's done over the, almost a year now since the eruption has ended and was going. it's managed to travel, not travel, but work its way uprift. Migrate uprift about a half a mile.
Right. So we're talking about this is area west of Highway 130, right? So you know those of you maybe are not quite as following where we are, like, you know, the area that of 130 that was cracked and had all the steel plates and got all covered up. That steaming area goes west of there into Ala'ili neighborhood, and you know it's an area we've been going and monitoring temperatures for a while. But even in that area, it's moved west to like the west end of that neighborhood where it was kind of before in the neighborhood area, kind of between the middle and 130 maybe, right? So it's kind of gone back down, back towards Pu'o'o, right, is where the steam is, right? And we had a live with Dr. Evgenia Ilyanskaya. I don't know, hopefully I got it right. I'm not going to try again.
A for effort.
And you know, we kind of all had more or less the same thinking that, you know, it's there is no fresh magma coming in there, but it's actually just like a part of the cooling process, right? And we discussed before, Dana and I have, you know, talking about steam from Fissure 8, how water has different lengths and paths to get down to the hot stuff underground, and how early on everything was steaming right away from the top of the ground, but then later on it took several days for all that big rain to get deep enough to where the heat had withdrawn to and come up to steam once again. And I think it's kind of more of the same, right? So we know that this area, farther up the rift you go, the magma is deeper and deeper, right? It didn't come to the surface until it get to the surface of Leilani. Even if it came up at an angle, it still didn't make it nearly as shallow under this area of Ala'ili as it did under Leilani. And
right. So what we're looking at here. So this is we are up rift, where the heavy steam is taking place, Malka of Highway 130, and then you were looking down the rift towards Fissure 8 and the rest of the Lower East Rift Zone eruption. So right here you can see that little mark would be Fissure 22. This would be Fissure 8. And you can see the highway would be somewhere in here-ish.
Right.
I'm not sure exactly. Can't tell. Anyways, the steam at the end of the eruption was basically in here, right? That was kind of the edge of where it was. It didn't go much further uprift than that. So with that in mind, I'm going to go ahead and play the video.
Right, yeah. So when this video pans around, you'll see how much more steam there is visible in this particular day. You know, obviously how much you see in each day depends on the weather, right? But like, this is a good day to see it, and so it was a good day to go and scout out how far the area had actually progressed. And so
yes, and in our surveys it was definitely not up here. We checked the jungle with thermal camera and could not tell that there was heat coming from anywhere in particular, and the vegetation was still green, basically telling us that there wasn't prolonged heat in that area either. And now there is. But really this is the only change, and this doesn't require any change into the magma. Like the magma below ground is going to be constant and all this is happening.
Yeah. So maybe we can go back to go to the tilt plots now, or GPS maybe. We might have to just start with here. So this is back on there, doesn't it?
Yeah, let's.
Where you give me control of the John Madden pen.
Oops, there we go.
All right, guys. So, okay. There's these two plots at the top of the Hawaii tracker page. This comes from the USGS page, of course, that show two station differences, right? It can tell us up here. It says UWEV-CRIM, right? Two stations. There's a difference between those stations, right? So this is a difference across the caldera. And so we're actually getting to the point where these are one-year plots, so we're kind of getting to the end. The collapses are almost all the way screwed off of this plot, and everything since then has been adjustments since the eruption ended, more or less, right? The eruption ending kind of right in there. And as far as some of the collapses, definitely ending right in there.
The pen.
Gotta get used to the fact that we have the pen. And
you gotta start John Madden. It's called the John Madden pen. You need to John Madden with it.
Right, so like right there, this is, the end of collapses happens right in here. Yeah, so across the caldera, we've looked at this station of the crater rim station, right? And we kind of have seen that station has been moving to the south, and the south caldera wall is part of the south flank to some degree, depending on how it stretches out. There's some messiness in there, but that piece of land can move in response to the south flank. We can leave it as simple as that, whether it does or when and how, maybe we don't know, but it can do that. And so it has been doing that for some time. We know the south flank has been moving quite a lot. In fact, in yesterday's update, HVO actually added a whole new sentence saying the south flank is moving, exceeding rates from before the eruption, which is not different from before. They're just actually acknowledging it and we've been writing now.
Yeah,
right?
And we've been saying that's been basically the driver the entire time post-eruption is that south flank move.
Yeah, so I would kind of posit to you guys. I mean, maybe let's take this, October to December, area right here, and let's see if I can draw a straight line. Not very straight, but that kind of rate might have been the rate of the south flank actually moving and causing affecting this signal, the distance between these stations to increase. Now, on top of that, I think we've actually deviated from that line up here, and maybe it happens right in here, or maybe it happens more clearly right in here, but somewhere in this range, like we're having an extra signal now stacked on here. And this is what I believe is probably the magma signal, the magma that's causing that bulge, which I believe because of the INSAR. Right. Kind of one thing by itself, like if I had just seen just this GPS plot and there was no evidence in the INSAR, I might say, okay, well, the south flank in this area maybe is moving faster all of a sudden. But because I see evidence of INSAR that wasn't there in its previous part of the plot, now I have, two lines of evidence to suggest that maybe this difference in the signal from this point forward is actually due to the magma coming in. And so what's interesting is, this has actually come in and it's kind of stabilized at a parallel line up here, so parallel right there, right? But it hasn't slowed back down and kind of resumed its previous track, right? So it may not actually recover. It may kind of build up and build up some more and build up some more to at some point it might reach a critical point.
Right.
But we're nowhere near there yet. This is like the beginning of the train that we're actually spotting right here.
The thing you're looking for at that point is gas. Where's the SO2?
The gas is the missing.
If it's coming shallow in any significant amount, see some gas coming out.
Yeah.
And we're still at that 100 tons a day roughly of SO2, which is still at all-time lows basically since the gas started to be accurately taken, the measurements. Right. So yeah, we're just at that point waiting for either the pickup in GPS or gas or something. But as of right now, Kilauea is just stirring a little.
Right. Yeah. So this is kind of that summit signal, and it's interesting to follow, but nothing seems to be happening very imminently. It's not moving very fast. If that line picks up, just going like this, and we'll say, okay, well, it looks like it might pop out. Kind of a good signal, right? But we don't see that yet, so I'm just going to go ahead and push we're over here.
You're lost.
I'm lost because I'm trying to. Oh, I see. It's because the mouse is. I'm lost. So let's look at the same thing at. Again.
Yeah.
Look at the Pu'o'o signal, and so the eruption happened here in August, and it collapses anyways, right? And lava kind of was still leaking out. We had a little resurgence of lava pushing up in September. Actually, September is probably more like in here, right? But like the beginning of the signal, I kind of saw like a little bit of lava burped out, and then there was an interesting little signal right in here, right? And
very end of the eruption, the last little stir.
Right. So in this case, like you actually had a deviation from this trend as it happened earlier on, right? Because you could almost say that this line, I'm really not good at drawing straight lines. I gotta try that one again. Try that one again. Better, right? Okay.
No art competition.
So that's a little trickier with the mouse, yeah. So right in the area, right in here, see we have a little bit of deviation, from the we'll call it in this case what appears to be a background trend, right? And we saw just above that this trend could be caused by both movement of the ground as well as injection of magma moving the ground out of the way, right? So it could be either one. This is kind of why I've been saying for a long time the jury's out.
Yeah, and also there's an additive one here where we know that the cone of Pu'uo'o has been collapsing such compromise, at least a couple of the stations, and not really sure where that influence exactly ends. Like we know that the ones on the cone are compromised.
Right.
These ones are measuring from the north side of the cone. I can't remember. 1,000 feet, I think, something like that from the cone. We can pull up a map, but and then across the Pu'uo'o down the valley to the Jacuzzi station.
Right. Yeah, and we'll scroll down and look at some of these stations, here in not super detail, but it's the same thing I've been saying, to repeat it again. But what I want to point out is like the deviation, whether it was caused by magma coming in, filling that spot, or it came by the actual ground settling, adjusting, either one of those is possible. But that adjustment seemed to have happened earlier on in this area of Pu'o, and then kind of stabilized after that since then.
Right.
So when we look at the individual station plots, I can actually kind of show you guys the pattern of this, right, geographically, because there are areas of the south flank that are clearly moving very fast, and other stations aren't showing movement that you would expect. And so there we can kind of draw a line on a map, maybe. So we check out the comments. We catch you in the comments.
Yeah, just
got any questions?
Just is there any to change? Not really, no. On either volcano, not really, no. Just he's not interested. It's like, okay, yeah, there is no real change, you know.
Yeah. So someone says that we're stalling. Is that what they're implying? That we're stalling because there's nothing to say?
Yeah. It's still pretty nuanced in a lot of regards.
Yeah, right? I mean, if that wasn't clear off the very top, right? You know, Kilauea is still a green. There hasn't been that much change. Mauna Loa is slightly increased. You know, the changes are not very significant at this point, and you know that's the end of that.
Right.
But you guys, you know, if we just said that and signed out, I don't think very many of you would be happy. So I'll kind of keep going with what I'm saying. You know, as we have been a pattern for a while. Those who are looking for more detail and the nuance of it. So. Can I
go ahead.
Point out some of these things on here? And I'm not sure I'll jump out on this because I want to scroll more than not. So, okay. At the Jacuzzi station, we can kind of see one of these stations right here is kind of showing a south trend, but it's not very fast and very clear. I'm going to focus on south flank stations once again, right? You know, the Jonica is actually showing movement to the north, stabilizing, right? Kind of this is the same pattern. These patterns haven't changed, you know, since that adjustment a few months after the eruption. So let's call it from the beginning of the year, right? January 2019 is right in here. I mean, these are very, very steady lines that we're seeing kind of in almost all the signals going across the board, right? Devil's Throat, close to the summit. It's actually still moving south, kind of similar to before in that case. Kind of New Yohamo is kind of showing similar movement to the north, similar to Jonica, right? There's a few stations very close to the rift zone. I'll show you guys on a map that kind of show these patterns of maybe kind of adjusting to the movement near the rift zone, and other ones that farther away don't show that at all.
Yeah.
So outlet, the summit, you know, this is the station south of the summit, kind of showing that south movement of that block of the South Caldera Fall. So they're still going, kind of all the same. Crater Rim, same thing going down, right? Byron's Ledge, nothing to see there. North Pu'o, that slight wiggle to the north, right? It's a little different from the Jacuzzi station. This is kind of maybe what you might see at the northern edge, the northern block of the rift zone, you know, depending on which block. You might have a loose one in there that wiggles back and forth. This station here is actually not PGV, but it's on the south flank. Yeah. And this is one of the ones that's actually showing faster movement. Here was the movement going south in the past at a lower rate and then sped up post-eruption. Like this is one of the important ones, this PG2R. The KTPN Kalapana Trail is maybe the one that's moving the fastest since then, right here, like going down much faster than before. And Hamo is kind of right on the rift zone once again. I'm kind of, you know, I'm saying these going to show you guys a map here shortly, right?
Yeah.
Kipukanene going down also. I'm almost to the end. Ainapo by the coast going down. Wood Point going down. And Helena Pali is also going down. So
all right. Yeah, then bring in the map.
Now we can look at the map, and I'll just recount, you know, what I just told you guys, and if you know, need to rewind to see what the data actually is, you can do so.
All right. So basically, we have this line. It's not exact. Do you want to draw it?
Yeah. Here's how this is not exact. Well, the split. Okay. Well, so I was going to draw the direction of the arrow, the ones that are really moving,
just
right?
But show like where it shifts from north to.
First, we put the data in, right? So here's Helena Pali. It's showing movement south, like pretty strong, right? So is Mane, right? It's kind of off, right? And here's our PG2R, also going that way. And here's right. Those are the four stations. They're really showing the most south like movement, but you also see it at a Pua Point and you see it at a Kaina Point right there. So that's clearly that area is all moving to the south, right? Now, anything north of that line right there, wait, right in there, right? That one. This stuff in here, especially within this range right in there, that's a rift zone, right, is adjusting, right? Because we know that this piece of land right here is moving to the south. No stations over here. Right? We only have the stations right in the middle. We don't have any to the north kind of to adjust to either, right? But that's kind of the situation here. That's why these stations right in the middle is Kamo and POC, and even, Jacuzzi maybe is far enough on the edge, right? That's showing a little bit of south movement, right? But these stations in the middle of this, like anything is fair game. Like, thing could wiggle any which way like a loose tooth, right? And that's why it's hard to believe or to base an interpretation based on the data like from right in here when we see this pattern outside of there that looks like this.
Especially by added local.
Yeah, just when we actually have a plot put up by HBO that shows exactly not this one, but the one we were using before this one.
Yeah, like it's and where does that disturbance top of it?
Right.
Type of. So it's just we do know the south flank is moving south at an accelerated rate, and that's still one of the biggest factors going for Kilauea.
And especially since it's doing so, like this station, especially up on the trail, right? So like somewhere right in here, it's really trucking this right in there. That whole thing is just
down,
going down, right? And everything else is kind of adjusting in response. So the fact that we see the GPS movement within the rift, in fact we can switch to the inflation and kind of maybe round it off. The tilt signals. That you might show some tilt, which all inflation, right? That may not actually be inflation due to magma, but inflation in the ground from the tilting of it, or how you want to define that term exactly.
So, first and foremost, we just had a bunch of rain on Kilauea, and tilt is very sensitive.
Right.
Sensitive enough that the day and night cycles affect it, the wind affects it, and rain affects it.
Yeah.
Such that Kilauea is now offline, basically.
Yeah. We'll stop transmitting, right? And so let's just go out at least to the week plot, because that 1-2 day plots is kind of too soon to really tell anything. And so the green line right there ending, that's our pool plot kind of going out of commission here at the right end of it. Right in there, yeah.
Oh.
Likes to go the big one. And the blue line is the summit, but it's also showing effects of that rain, yeah. It doesn't always rain as hard at the summit as it does on the rift zone, but in this case, in the last couple of days, it did rain quite a bit up there at the summit of Kilauea. So, let's kind of just scroll down. Let me see if I can find anything that's worth pointing out to you guys here, right? To kind of look at summer camp, we can see that there's two components of the same station, right? So it's been tilting away from some center. So it could be doing that in response to magma. It likely is. It's not doing that very fast in any way that tells us anything useful that everything else we've talked about doesn't tell us.
Right.
Once again, like the tilt kind of becomes most useful when you're looking at that kind of orange alert going to red time period when lava is actually moving through and out somewhere. You can really get some use of it.
One general note is it's a little bit, generally a little bit, tilt's more useful on Kilauea than it would be on Mauna Loa. Like, the magma chamber is just too deep. The shallow chamber at Kilauea, we kind of expect to be able to see things with. Whereas Mauna Loa, it's like when it's getting ready to erupt, then we see things. There is some nuance to the Kilauea stations, but
absolutely, yeah. I mean, I do have to throw out there that Mauna Loa, there's a lot that we don't know about Mauna Loa. I may well easily have that shallow chamber that hasn't been activated that the tilt meter would be useful for. But the thing is, Mauna Loa has not been erupting for a long time, so we have not spent as much energy in monitoring it, right? So our network on Kilauea is already way better. So that in itself helps us tell a lot more about Kilauea, and we have a long history of measuring tilt on Kilauea, which gives us like a historical context, right? Even if we can say, well, what Jagger did in the Whitney Vault wasn't perfect, it was a lot. It was pretty good, and it's actually a data you can actually use nowadays, right? We don't have that at some of Mauna Loa, right? We have signals on the Whitney Vault that measure Mauna Loa from there, right? That's what we have. So it's a lot trickier, right? And we don't, it's a lot harder to get up there and to actually deploy an instrument and maintain it and keep it operational through all the weather and everything else that we have, right? And those are just natural barriers to why it made sense to invest on Kilauea, right? And kind of, just block out that whole.
Yeah, that's actually a pretty good. It changed on accident, but that's actually a pretty good marker. Just discount that stuff. Just discount it because rain.
Yeah. So I mean, the scale on here, kind of might be showing something like 5 micro readings over a month. It's just not enough to really say anything that means anything about, right? So
Yeah, I think with that, there's really not much more to dive into at this time.
It's just, yeah. I mean, we'll wrap it up here real quick. I just want to maybe
Right.
share with the audience something I was just sharing with you before I started with talking about Mike Poland, right? I was talking, Mike Poland had an update on Yellowstone, which was great, and I really like the USGS doing their video updates also. But he showed some GPS and plots on there as well, and yeah, we were talking about how there's seasonal changes that happen on Yellowstone, just from snow melt and water moving through the system, right? There was, let's want to acknowledge that we had that big earthquake in California last week. Well, two big ones, really, right? And a lot of smaller ones, right? But, there's a lot of kind of knock-on effect of people talking about how that affects things. And, Mike posted again about how these hydrothermal systems, right? The water table moving underground is doing a lot of the fracturing of rock, and a lot of times these earthquakes are actually moving the water on a rock, fractures of rock, and they can tell this most obviously in Yellowstone because they have geysers, and they might have after a big earthquake in the past, like an extra 100 geysers activate, showing that a lot of these variations happening are actually caused by the groundwater, and maybe that's what I want to personally like emphasize here at the end is like, we know we have a whole lot of rain happening, right? We know we have a whole lot of movement of the ground happening. We don't know what's what necessarily, right? We know that the scale of it's about the same, and if the scale is about the same and it's not big enough to be caused by the actual magma from the volcano, then that's where we stand volcanically, right? There's not really a whole spread from there. We're kind of watching all the signals, and everything we see at some point is the background of how this thing lives and breathes when it's not erupting.
All right, so last thing I want to talk about is Dr. Ilyanskaya. She's going to be doing some catchment samples around Puna, like Upper Puna, Lower Puna, probably mostly Lower Puna, because what her research indicated that she shared with us. And she's looking for more of the trace elements that were deposited from the volcanic eruption. And her research would lead her to believe that it's probably in a lot of our catchment tanks still.
Right.
Especially if you didn't drain it and wash it all out. Even if you took like half of it out and balance the pH and all kinds of stuff, they're still probably at the bottom.
Yeah, and some of these are like metallic ions, right?
Yeah,
so
exactly.
They could be ones that are kind of lingering.
So I wrote a post today that is on Hawaii Tracker. And in it, if you want to volunteer, she's talking about doing this on July 14th, 15th, collecting samples.
Mm-hmm.
So would run around and try and collect as many samples as possible. If you help contribute, this is just going to help with furthering understanding the health impacts of volcanic gases in an eruption, in the future. And it will even help understand kind of more of the risks more of the hazards that experience.
That's right.
But more than just the understanding of SO2, it's talking about all the trace particulates and everything as well. So it's really cool research.
Yeah, exactly. Yeah, I mean, those guys came. I remember with their first round of research at Kilauea back in 2008, maybe with the lava lake, or maybe it was a little after that. And something like 1 ton of dissolved metals came out of that summit plume every day. Things like gold and lead and copper and arsenic and things. Right. So that's likely the same kind of stuff that was coming out of the ground down here, and that's the kind of thing she's trying to figure out. Where did it go? Did it actually, is it affecting people? And so that's something we really would like to know.
Right. So I cleaned up some of the audio, edited down the podcast we did with the professor, and I'm going to be posting it to YouTube pretty soon, with trying to improve some of the audio on it, and then you want to get a real grasp of some of the research that she's doing. That'd be the place to do it.
Right. Yeah.
That'll be coming pretty soon. And with that, I think we're pretty much.
There was one more thing, which is coming up, right? Which is Saturday.
Oh, Saturday. Yes, we should mention that. The DNLR has proposed the Malama Flats area for an alternative boat ramp site.
Tupuoiki.
Yeah, Tupuoiki, as it was been closed off from sand following the eruption.
Right.
This would be the time if you have a plan or a different proposal or anything that can help DNLR, or would assist DNLR in their trying to figure out what is the future of the Puna boat ramp. That would be the place to do it. That's going to be Sacred Hearts Church at 1, I believe, on
1
Saturday.
to 3 p.m., I believe.
Right.
Yeah, Saturday, yeah. So, Dean had a great interview with Mike Trask, fishermen, long-time fishermen in the area. So you guys should check that out if you missed it as well.
Right, and that'll also be uploaded to the YouTube with updated audio. I'll try to get that pretty soon.
Encourage anyone who has that kind of voice to come and speak. Yeah, like we'd like to kind of make sure it doesn't get derailed. That we kind of focus on in my mind being productive. Right, like I think personally, everything I've heard is that not anyone that I've talked to really thinks Mama Flats is a great place for a boat ramp.
No.
So I think, hopefully we can express that and why that's the case, and kind of get past that and move on to some alternatives, right? Including ideas have been floated about trying to clean up Hawaiian ramp as it is, which I personally don't think is that viable. We can talk about that in the future. About sand and lava risk and all that.
That's a whole thing. Yeah. So that might be a future update. But
that's right. Yeah, we'll talk more about this. On Saturday maybe. But all the proposals as well, like on the new lava airport wiki. Is a place that we're looking at closely. And others have as well.
We actually. So all right, guys. Well, thank you very much for joining us today. And with that, stay classy, Puna. Yeah.
Stay classy, Puna.